remote and unattended, and with wind-generated energy, they provide telephone, telex, and television links, and send and receive information from satellites. For centuries, man has looked to the wind and the sun as sources of power. However, never before have they attracted so much attention as they do today because of the worldwide oil crisis. 50 kilometers away is the next microwave link, powered silently by the winds of the Nullarbor. In Port Adelaide, too, the wind has been harnessed. It provides power for the channel lights that guide ships in and out of port. A different kind of remoteness here, not as vast as the desert, but still a costly location for running power lines from the shore to every beacon. It is through such projects that Australian researchers and manufacturers have been able to apply the results of years of work on alternative energy sources. They're now working with new urgency and greater incentives, and their achievements are attracting worldwide attention. In the field of solar cells, for example, Australia has helped pioneer their use with the world's longest solar-powered communications link. The system uses shipping containers topped with solar cells and filled with batteries. The cells convert sunlight into battery-stored electricity. These solar powerhouses provide all the energy needed to operate the telecommunications service between Tennant Creek and Alice Springs, a distance of more than 600 kilometers. Solar cells are made of thin slices of silicon and traces of other elements baked in diffusion furnaces at 1200 degrees centigrade. Most of the Australian-made cells or integrated circuits come from the Philips factory at Hendon in Adelaide. The technology involved in their manufacture is similar to that used to make chips, the tiny integrated circuits that have made space travel possible, and which are today used in thousands of everyday products, from computers to washing machines. Production takes place in rooms where the air is filtered once every 6 seconds to remove any particle of dust larger than 1/300th the diameter of a human hair. The manufacturing and testing processes require sophisticated technology, but the blades for windmill propellers are fashioned by hand from one of the oldest materials known to man, wood. Here, different skills are needed, both in the aerodynamic design of the blades and in shaping them to critical dimensions. The power generators that will be driven by the wind are also designed and manufactured in Australia. Their reliability and performance have resulted in export orders from around the world. Although wind-driven generators and windmills have been around for many years, this is one of the most sophisticated wind turbines commercially available. It has a brushless alternator that produces a direct current output. The alternator is driven by a 5-to-1 step-up gearbox linked to the propeller-driven turbine. The simple windmills of the horse and buggy days were quite primitive when compared with the sophisticated generators now being made. The latest design incorporates advanced electronics to control its operations. At the heart of the electronics is a microprocessor, a tiny chip which contains a specially designed program for power generating, monitoring, and control. But if the wind can be harnessed to produce power, and so can the sun, why not combine both these renewable energy resources in one installation? The proposition was put to the National Energy Research, Development and Demonstration Council, and it decided to finance an experiment in which the two were combined. And so, from Australia, came the world's first hybrid energy system. To test it in a practical application, the new wind and solar energy system was hooked up to the wiring of an all-electric house at Gawler in South Australia. The backyard gained some installations that really upstaged the clothes hoist. Almost like an omen, a wind-borne glider passed overhead as the generator was installed on its tower. The Dunlight Company provided the wind energy component of the hybrid system, Philips the panels of solar cells. Overall control of the experiment was in the hands of Dunlight engineers. The tower was severely tested by gale force winds, which caused havoc in the area shortly after it was installed. But right from the start, the hybrid system worked faultlessly. The propellers of the turbine have an automatic feathering mechanism that works with great precision, limiting its speed to less than 220 revolutions a minute. This prevents excessive speed in high wind that could cause it to self-destruct. The arrays of solar panels were mounted facing north on top of a container and set at a specific angle that made maximum use of the sun's rays. Inside the container was a standby generator powered by a diesel engine. It would supply power in an emergency should the hybrid alternative energy sources break down. Because the household's demands for power don't necessarily coincide with sunlight or wind, the energy from these sources must be stored in banks of batteries. But the power stored in such batteries is 110 volts direct current. Australian homes, including the one in the test project, use 240 volts alternating current. So to convert the power in the batteries to 240 volts AC, the container of batteries was fitted with an electronically regulated conversion system, specially designed for the project. Once the hybrid energy system was operating according to specifications, the normal electricity supply to the house was cut off. The sun and the wind took over, without much more than a flicker. For the next 6 months, the home of Mark and Marilyn Maloney at Gawler would depend on the system for every power need. They made no changes to their lifestyle. They used power as they'd always done. But for 6 months, they had no power bills. The storage batteries have a capacity of 55 kilowatt hours. That's enough to run the household for 5 days without recharging. If there should be insufficient wind or sun and the batteries become flat, electronic controls would automatically start up the diesel engine and recharge the batteries. And if the batteries should break down for other reasons, the microprocessor in the control unit would instruct the diesel to bypass the batteries and supply 240 volts of power direct to the house. But during the entire 6 months of the test program, the diesel engine remained idle. It was never needed. The research project cost more than $140,000. It was designed not only to show that the system worked, but to provide a mass of information about how well it worked so that further improvements can be made. The hybrid energy system is seen as ideal for installation on properties and establishments remote from conventional fuel sources, generally costing much less than the extension of power lines or the use of oil-burning generating plants. It's also seen as having great potential for use overseas, particularly in underdeveloped countries with remote areas not linked to electricity grids. Intricate control systems and microcomputers in the storage container in the backyard monitored the entire operation. The recording equipment provided engineers with a continuous printout of performance information, the amount of energy generated by the sun and by the wind, the potential of the battery banks, the amount of power used, and when. The performance data collected during the experiment is now being evaluated, but the companies involved are convinced that the hybrid energy system is commercially feasible. Potential markets are now being investigated. It's estimated that there are up to 20,000 sites in Australia alone that could economically use the hybrid energy system. And in a world becoming increasingly aware of the need to find new sources of energy and to reduce the cost of energy, this Australian development could play an important role.